thanks for coming, everyone. I'm Michel Lebeau. I'm a consultant here at ECS. I've been here for a bit more than 3 years now. As Bia just said, we are a DevOps consultancy, so I do a lot of that. In the last year or so, I've been at a large UK bank just trying to enable them to do cloud. So mostly focused on Amazon, using a lot of Terraform. I also do the official trainings for HashiCorp. So you didn't hear a lot of Google Cloud or CloudBuild. That's because I'm not an expert in any of that. So if you have some very hard questions, I'm probably not the best person to answer them. But I think CloudBuild is pretty cool, and we'll talk about that today. So, quick overview of what we're going to build tonight. Then we'll talk about Google Cloud Build. We'll talk about App Engine, and then we get our hands-on. So this is a hands-on meetup, meaning that we actually got already an IP, more specifically a domain name, and you will be able to log into an instance. We'll get to why you can't log in at the moment, don't worry. And then you will do something yourself. And we'll finish up with some food and drinks. So what are we going to do tonight? I've already built an EC2 instance, and I've given that EC2 instance a GCP service account. So what you're going to do is that you're going to log into that instance. Then you're going to run CloudBuild. And you're going to do that 3 times. The first time, you're going to actually do a very basic build. That basic build will run go install, and then go build. Then we're going to run a beta build, where we're actually going to add some automated tests. The last one will actually be even better, because we are going to actually take our new application and deploy it to App Engine. So, what is Google Cloud Build? Who has used Cloud Build before? Right, it's around 5 people, not bad. So it's very text heavy, but I'll try to not just read my screen. Basically, Cloud Build is a service that's managed by Google Cloud, so you don't have to manage anything yourself, as in, think about Jenkins. You don't have to own the master or the slaves. It's just a pure SaaS system. You're going to give your source code to Cloud Build and give it some steps to run, and Google will just run these steps and then do something with your artifact. Now, how does it actually work? It's going to create a new Docker container for every single step of your pipeline. So imagine if you're using, let's say, Jenkins, you will have a pipeline, and that pipeline will run different commands. Here is the same thing, but every command is run in a different Docker container. The good thing is that the data can actually be shared between the containers, so it's not starting from scratch again and again. So there are some common images that are made using some very common tools, which means that when you want to run a command, you actually just use that command's container. So examples would be gcloud, git, go, gradle, etc. But it doesn't cover all of the tools. So there is a community repository which actually contains a lot of other tools, which are sometimes a bit more obscure. You can see the list: address CLI, boot, BQ, etc. If you want, you can actually just create your own. In the end, it's just with Docker containers. So as long as you can create your own Docker file, you'll be good. Now, in practice, what does it look like? It looks like a YAML file or a JSON file. That's all there is, really. You're going to write a configuration file in YAML or JSON, and Google will just read that configuration file and do what you describe inside your configuration file. So it's not code, right? It's more like a configuration language. Something that's important is that every time you run Cloud Build, you're going to have a build log, and that build log will be stored in Google Cloud Storage. So Google Cloud Storage is a bit like the S3 of Google Cloud. If you don't like hard coding any secrets in your configuration, which you shouldn't, you can actually integrate it with KMS from Google Cloud, and you can just retrieve secrets as needed, so that you don't just hard code them in your code, in your configuration. And at the end of your build, you might actually want to store your artifacts. It's really nice to build something, but it's also even better to actually do something with what you build. So in practice, the interface is, I would say, a bit lackluster. You don't get a very, very nice interface where you can see the entire pipeline. is just going to look like that when you look at the interface. And tonight, we are not even going to look at the interface. We are just going to use the CLI. And you will see it's very simple. But ultimately, you will see your build status. You will see the source, like the code that you used to build your application, and then the build steps. And here you will see the logs. So just very simple, very, let's say, basic on the interface. All right, now you know CloudBuild. You are experts in that. So let's talk about App Engine, sorry. Who has used App Engine before? Around 5 people again. All right. So App Engine is basically the platform as service offering of Google Cloud. You've got some application that needs to run somewhere. You just give it to App Engine, and in theory, it's going to run it for you. I say in theory because it has some limitations that we'll talk about. If you want to have different versions of your application, let's say you've got version 1, and then you want to deploy version 2, but not just redirect all of the traffic straight to version 2. Maybe you want to do canary release or just a running release. You can do that very easily with App Engine. Based on the version that you use, we'll get to that, you can actually scale from 0 to, in theory, the infinite. In practice, of course not. But the scaling to 0 is actually quite nice. If your application has no traffic, then you can just scale it to 0. You have no infrastructure running, and that costs you absolutely 0, which is quite nice. By default, you get some HTTPS endpoint. You will see that. And there are 2 environments. So quickly, you've got a standard environment. This one, you're very limited. So you're limited to specific versions of some languages. The good thing with that with that environment, is that actually it starts extremely quickly. You will see that's what we are going to use. It starts in seconds. So if you have no traffic, you get 0 application instance running. Then if you get traffic, after a few seconds, there it is. Your application is up, which is quite nice. Now, if you need more flexibility, if you need to go outside of these boundaries, you can use the flexible environment. And that's going to support much more capabilities. Here is going to start slower, but it can actually keep that running for an hour. So that can actually handle background processes, whereas standard environment doesn't. And you need at least 1 instance. Now again, the interface of App Engine it's okay. There is what you need, but not much more. Here you can see there is no data actually, because I wasn't running anything. But it's basically a summary of counts per second. You can see some more summaries, and you can see your dashboard, all of the services that you have running, all of your versions, instances, etc. So let's say the Google Cloud API interface gives you what you need, but not much more, in a way. All right, I've talked enough. Now we'll get hands-on. So for the hands-on, you need to connect to the Wi-Fi. So I hope you brought your laptop. If you didn't bring your laptop, that should actually work on your phone, but it's probably a bit better on your laptop. So Wi-Fi is going to be DevOps playground. You need to just put some information in there, and you'll be connected. Then I'd like you to go on this URL. That's going to bring you to a GitHub repository, where you will see the steps that we are going to take today, and it's going to be a bit easier to just copy and paste. Now, when you're on this, you've got this README in front of you. What you should do is look at the piece of paper you are given and log into the URL you have. When you go on that URL in your browser, you will actually be prompted for just in your SSH prompt. So here you will want to log in with user playground and the password ECS digital. Now, if you look very carefully at your pieces of paper, you will see that it's actually inverted. That's why if you try to log into that instance earlier, it probably didn't work. Right, is everyone connected? Who has trouble connecting? So your SSH credentials, are you using that? Or are you using what's on the piece of paper? So the piece of paper has the password and username inverted. There it is. Any other issues connecting? So you should be able to get on this web page, and that should bring you to GitHub. All done? Right. Now, don't go ahead and do the steps, otherwise you're going to spoil yourself. So give it a second for everyone to connect. All right. So here you should have two things. Actually, before I start, does anyone have Collie? C-O-L-L-I-E? Because actually I need one for myself. Otherwise I can't show you. Yes, so anyone has Collie? Yes, C-O-L-L-I-E. I guess if no one does, then I can use it. So I'm going to have two windows. I'm going to have my SSH terminal, and I'm going to have my README here. I'm going to make it a bit easier. So I've listed a few prerequisites if you wanted to actually do something similar yourself, some things that you should know. And also, GitHub formatting can be a bit finicky sometimes. So there are plenty of permissions that are needed to actually do this playground. So what we're doing here is that I've created a service account in Google Cloud. So create a new project, create a service account. Then with this service account, I've created like 70 new service accounts. And I've given them all of these permissions so that you are able to actually run through the playground. So when you're going to run through the playground, you're going to do it with that service account here. So the very first step is SSHing into your workstation. It looks like everyone has done that, so well done. Next one, we're going to go into the project directory. So if you go into that project directory, you will see that you have quite a few files underneath. Now I hope you can see a progression here. We're going to go from app 1, which is a very standard one, basic one, to app 2, which has the automated test, then to app 3, which is going to actually deploy to App Engine. So let's look at our app 1. So just to make sure we understand how that's working actually, if you look in your root directory, you will see that you've got something called keyfile.json, which is basically your current service account, the one that you're going to use during this playground. Right. How is everything? All right, so we're going to use this service account here. Your gcloud command line utility has already been configured for it. So I'm going to make it look very easy, but there is a bit of setup that happened in the background before you actually logged into the machine. Now, you can try to guess how we did that originally. It was with Terraform. So let's go in projects. App 1. Now we've got two files in here, so it's very simple. So let's have a look at our application file. So our application file is main.go. It's a very simple hello world Golang application. And you can see what it does. It does one thing. It probably does it extremely well, but it only does one thing, which is print hello world. Right? Then our build configuration is going to be cloudbuild.yml. And our cloudbuild.yml is going to have two simple steps. The first one is going to run the go command. You can see this is the official cloud builders. So these are the ones that are just basically a command line utility or a framework that's contained within one container. So here we can just call the container and then run different commands. So here we're just going to run go install. And after that, we'll just run go build. And we're specifying an environment variable for the project root, which is going to be playground. So that's all you need. That's your pipeline defined. Now the next step is just running gcloud build submit, and we actually specify our cloud build configuration file. So if you run that, you will see that it's going to take your application, your configuration file, and just run the pipeline. How are you guys doing?
I can't get to that address via browser or SSH.
Really?
I've got another one, and I've got a default Nginx page, like it's not done properly, so I've got a different one of these. And
Okay.
it's not
This
loading.
one comes up okay on mine. So do you want to try DuckLoop?
This is a direct SSH to it, or
No, this is so it's just in your web browser. Go to that address. It's
done. Oh.
Yeah.
Yeah, that one.
Yeah, sorry. Right, did it work for everyone? Yep. Right, how happy are we with our build here? Is it a complete build? So in theory, yes. But actually, if we had to ask ourselves, some questions, what could you add here? What could we consider is actually missing in this configuration or in this pipeline?
Tests.
Yes. So it's very nice to be able to automate a build. If you can also automate the tests that go with that build, it will tell you, if your build is actually messed up in a way. Another question is, what can you do to actually speed that process up? So here, remember, we ran it once. It's fine. If you run it again, you're going to do the same thing again. You're going to send your data again, and you're going to run the same commands again. What if you had a more complicated pipeline and maybe a much heavier application? Let's say your application was actually much heavier, like hundreds of megs. Is there anything you could do to make it a bit faster? Yes. What I would do is try to cache some data so that actually you don't need to send the data again and again and again every time you build something. All right, so as someone said, automated test, that's the next step. So let's jump into our app2 directory. Now, let's have a look at our main.go application. That hasn't changed. Same application. The only thing that we are changing here is we're adding a main_test file. Now that's using the testing package from Go. And here we're just creating one single function that's going to test our other function. And what we are testing is that our hello function here returns hello world. Now it's all static, there's nothing dynamic, so it shouldn't go wrong. But knowing me, it could. And lastly, we're going to look at our CloudBuild application configuration. You can see it hasn't changed much. We are just adding one thing, which is here go test. And you can see I'm using the V flag because I want it to be a bit more verbose. The reason I'm doing that is that if go tests work, they don't actually output anything, which is a bit boring for a playground. So let's run the same command again. Let's build. So again, we run the exact same command, and here CloudBuild will take our new configuration file and we'll run our tests. So as you can see here, we've got step 0, step 1, step 2. This is very, say, developer-centric. Everything that most of the services in Google Cloud, from what I've seen compared to, let's say, Amazon, is much more developer-centric, meaning that I would guess if that was on Amazon, the index would start at 1, like step 1, step 2, step 3. Here you can see it's step 0, step 1, step 2. So yes, as you can see here, our step 2, which is our automated test, works. So well done. You've done automated tests using CloudBuild. Now, quick question. What kind of test is that? Yes, it's a unit test. What other kind of tests could we do? So there is integration test, yeah? What else? Functional test. Regression. You could do acceptance. You could do UI. There's a lot of different kind of tests that we could do. In this case, our application is simple enough that, yeah, we're happy with just one unit test. Don't say anyone I said that. Now, stage 3 is going to be a bit more complex, but don't worry, you'll manage. So stage 3 has 4 files. We can see there is a new app.yaml file. So that app.yaml file is going to help us define what is going to happen on App Engine. This is how we configure our application being deployed on App Engine. So we specify the runtime. We need to use Go. Otherwise, our Go application will have trouble working. API version, that's fine. Service name, here default. So we'll get to that. We'll change it. If everyone runs this command with service default, it means that everyone will deploy to the same service, meaning that you'll just kind of override it again and again. So we'll have to change that. And then we're seeing here with our handlers that for any URL, we are going to just send traffic to our Go application. So talking about our Go application, let's have a look. Now this is slightly more complex. You can see I'm importing the net HTTP package and here the App Engine package. You do need to import and use that when you're going to use App Engine. It's sadly not a simple drag and drop of your application to App Engine. You do need to modify your application a bit. And we got a function called server. And in our main function, we're just sending all the traffic to our server function. And then we're calling App Engine main. Essentially, that's a very simple web server. That's all it is. Now, how do we test our very simple web server? Sorry. We are just going to test our server function. We're going to send it some fake traffic. And as a return, we are going to check that we get the right response. So far, simple, right? What else we have? All right, our CloudBuild configuration file. Now you can see that changes a bit. The very first step is going to be go get something. Where do we need that? Yes, so here our build has some dependencies. So we are using a package. We need to get that package. Next one, we're going to run go build, same as before. Then we're going to do go test. So again, we run our suite of tests. And the last one is a new one. So we are using gcloud. Again, that's a default builder that comes with gcloud. And you can just run app deploy. By default, if you run app deploy and you don't specify which configuration file to use, you need to use app.yml. So lucky us, it's already called app.yml. And that's it. So before you run that, let's do our small change. So we want to go into app.yml. And what I'd like you to do is to actually change the service here. So I would recommend you change it to like the name of the animal of your server. Like in my case, it's collie. But people have squirrel and other kinds of animals. Or just change it to your name or something that will be unique to you. If you leave it to default, again, you're just going to override each other. Everyone okay with that? All right. So now we are just going to run the exact same command as before. And we can look at the output of our build. So what does it do? It gets our source code. Then it's going to run go get our dependency. Nice, finished. Next one, we are just going to run go build. That seems to work. Go test. Hopefully it passes. Yes, it did. And the last one will be actually we want to deploy. So now, as you can see, there is some output here. So I'm targeting the collie service, and it even gives me a target URL. So automatically, without me doing anything at all, it's going to give me a URL here. I don't know if you noticed so far, but this thing here kind of comes back, again and again and again. So this entire string here is the name of our project. So we are all in the same GCP project, which means that we are all under that. And here, because I'm targeting the collie service, then it's doing something clever, which is creating a new domain called collie dot. But it's all in the same domain actually. Now, it seems like it's all done, so let's have a look. If I go to this URL, hello DevOps Playground. Well done. Did it not work for anyone? Ah. Right, did it fail for anyone? Oh, so it's still running. Okay, that's good. Now if it fails, you tell me. And I'll just blame you. How many failures? I'm talking about the builds, right? Not you. Step 0? Oh, it's still there. Oh, it's slow? Oh. Mine's fast. So if we have a quick look at our services currently running, we've got quite a few here. And we can see people who use their animal name. Yeah, so default, that's me doing testing in the last few days. And the test here is me doing some more testing, as you can guess. So again, if you want to see the result of your build, you can just look at the target URL. So copy that in another tab, and you should be able to see the output of your magnificent application. Now Sheepdog is already at version 2. He's got quite a lead. Right? Is it failing for anyone? Or just slow? Oh.
Credentials, something. requires authentication.
You probably didn't go to the right one. Yeah.
Okay.
So let me show you. So the URL you want to go to is the one that's against target URL here. And again, it's shown here. So what you tried to access was something else, which is the logs exactly. And in order to see the logs, you will need to have the right rights to cloud storage. Just very slow. Nice.
So initially there was some authentication problem, but
Nice, okay?
seems to be going through now.
Okay.
Yeah, considering that we're all running on Wi-Fi, I wouldn't be surprised if something.
Yeah, but so in theory, you're all running all of that from different instances in Amazon. So you shouldn't impact yourself. No, the office is quite busy during the day. Oh,
Failed.
so
There's not much expression.
okay, show me your app.yaml.
Let's change it to
All lowercase, please.
plain black.
Yeah.
Yeah, doesn't have a
Yeah.
capital.
So the service name should be all lowercase.
So we'll go through now.
Looks like it is going through, yeah. And then you will be able to see it at this URL. How is that looking? Perfect. All right, any other issues? Nice. So now we've got a bit of extra time, so we are going to play around with our application, and we are just going to change the output text. Now, if we only change the output text of our application, what's going to happen? Yes, the test will fail because the tests are looking for something very specific, which is not what your new text would be. So we're going to go ahead and try to change both. So looking at your main.go file, you will want to update this string here. So we can do it together. So maybe change it to say something like, hello, I'm Michel, and put your name, so that we'll have something different, which will make it a bit more interesting. So when you have changed your application output, go ahead and have a look at your test file and change that too. Now believe me, if you don't input it in the same way, or if you have a missing comma or an exclamation mark that's missing, the test will fail and your build will fail. So I'm actually going to do that. So when you have changed your output on both sides, then go ahead and run your build. And you will see. You will see if you did a good job or a pretty poor job. So what's happening on my side here? We've got our build, we've got go get dependencies, we've got go build, go test, and it fails. So again, what happened here? Yes, the test failed. So what happened exactly? Silly me. My test is expecting hello at Michel. Oh, sorry, my test got hello at Michel with no joy or energy in it. And my test actually expected a lot of joy. So let's fix that. Let's add a bit of joy and run that again. So if you didn't mess up, you should have your new service version already deployed. Unlike me. Oh, Michel.
We have both misspelled Michael's.
I disagree. Oh, really? What is it? Michel. It's okay, Michael. Alright, so now we can see that the test passed. Well done, me. And then it's actually deploying my application. So deploying the application is always done in 2 steps. The first one is just updating service, creating a new version. And the second step is actually moving traffic from the old version to the new version. And there we are. So now if I refresh that, right, who cheated? So pizza should be here, in theory, in 3 minutes. Now that's counting on Papa John's punctuality. We'll see how that works. So I'm guessing someone changed my application code. No, someone deployed to my service. How dare you? That's the risk. If you don't segregate people enough, then they're going to mess up with your stuff. At least it's still working, right? Someone could have just destroyed everything, so at least I'm lucky. So that's about it for the hands-on part. So we're kind of waiting for the pizza now. So is there any questions? Oh yeah. Go ahead. Who has questions? Oh.
So, what's the benefit between this and running your own Jenkins machine?
So again, I haven't used that a lot. I've only used it for this experience here, but I would say that you don't have to manage Jenkins. If you have had to manage Jenkins, let's say masters or slaves, I've seen masters with something like 18,000 developers. There were lots of big masters, and it was actually a bit tough to make it scale that much. Here, you don't have to worry about it. Saving for the slaves, having to have that compute capacity, either if it's on-premise, always there, or if it's on-prem doing scaling up and down, you don't have to manage that.
If we go back to the CloudBuild.yaml,
Yes.
so each of those steps is running a new container,
Yes.
but are those, all of them are sharing the same volume, or every time you run a new step, create a new volume, a Docker volume?
So they are all sharing the same. By default, they are not, but here I'm actually using that volume here to be able to do that, to be able to share the same code across different containers.
Okay. And are we running here Docker inside Docker, like an image inside another image in the Google Cloud? Or
So I don't know if it's Docker within Docker or if
Okay.
it's Docker within something else. We don't actually have that visibility. All you know is that you're running Docker. Maybe someone knows actually the answer to that question, but all I know is that it's just Docker, and I don't need to really know what's outside. Now it's because I haven't done anything complex. If I wanted to do something very complicated, it's possible that I might actually need to understand that.
Okay. Okay, thanks, man.
Any other question?
What kind of reporting tools go with this?
So
For test metrics, etc., coverage.
there is no test coverage tools out of the box here.
Okay.
The metrics that you can see, I will show you right away. So here you can see, it's quite nice because I've got some data to show now.
Yay.
So good timing. So summary here, you've got a few different things that you can look at. Summary is to look at the count, how many times, how many requests did my application get. And you can see in total here around 2 per second, which was a lot of traffic compared to before. You can see some summary around the billing. So usage 4 instance hours, which is going to cost me absolutely nothing because that's not expensive, which is quite nice. You can see what has been accessed, how many requests per minute to just slash, 54. And you can see some data here. There is something that you can see, which is around logs and debugging. So Stackdriver comes, let's say, out of the box with Google Cloud, and is going to give you some more logs. You can actually integrate your application with Stackdriver a bit more to make it give you more logs, more debugging capabilities. So here, if you go in the debug tab, I hope you can see properly. If you were actually using the right libraries, it would enable you to do some very quick on-the-go, like real-time debugging through that. So I would say Google Cloud in general is very developer-oriented, meaning that you got loads of tools for developers to do stuff, but it's also less easy to use for, let's say, a standard user who doesn't want to get too technical, compared to something with a very nice UI. So I end up doing a lot of things using just the CLI with Google Cloud, whereas I maybe wouldn't do that as much with Amazon.
Thank you. So is this a replacement for Jenkins? So what runs these commands and monitors it and tells people if it passed or failed or?
So you can create triggers. You can say every time there is a new push to that repository, you're going to have a trigger on that that's going to create a new build. So instead of you running the command gcloud run my build, you could just have something automated that looks at your current code repository.
Right.
And when there is a change, take that, run your build, your test, and possibly deploy if you want.
So there's no GUI though, it just happens.
So I can show you all there is in terms of GUI, which is going to be down there in CloudBuild. And CloudBuild is going to have two things here. So the history. So if you look at this one, which happened 1 minute ago, you can see go get, go build, go test, gcloud app deploy, and you can see the log of your deployments. That's all you really get. And if you wanted, you could just rebuild it, or if it was in progress, you could cancel it. Again, that's about it. And here you got the triggers. So triggers allow you to really say, when on this repository there is just a new version of the code, just try to build that. You don't have to deploy automatically based on every single new version, but at least it can tell you very quickly if your new code version has an issue, because optimally it would run some suite of tests.
Okay, yeah. So say you've got Google Kubernetes engine or something, and you've got loads of different services, and you're deploying or using Helm or sort of more complex use cases. Does it work for that, or is it mainly for the app engine, like simple deploying to the app engine?
So it would work with more or less anything, as long as you can have a container that does it for you or run a script that does it for you.
Right,
So
yeah,
for GKE, you could very easily say, just deploy that in GKE, and it would work. Yeah.
Okay. Yep. Cool.
Any other question? As you can see, the pizza have not arrived, so you can ask some more questions. Any other question? So actually, I've got a question for you. For someone who has used CloudBuild before, what has been your experience so far? Because I had a few hands raised when I asked who has used CloudBuild before. Who wants to give his perspective? Right, there's someone. Thank you.
Yeah, we found it pretty good actually. It's been very fast as well. I think actually the speed of spinning up builds compared with other things we've used has been impressive, even when you've got a lot of parallel builds going on. So yeah, we've been pleased.
What kind of things are you doing with CloudBuild?
So we're doing things like building assets to push out to our CDN for front-end code. So we deploy a site, but we also want to make sure the front-end assets are there. So we'll go through build steps that run NPM, pull everything down, do a build using Webpack, and then push the results into Google Cloud Storage, where then they're served out to customers from there.
Sweet. And has there been anything that you tried to do but just couldn't do because you're limited?
No. I think we've been able to do everything we tried to do so far. I was just talking to Thomas here also though about the fact that we hadn't really played with the encrypted secrets stuff, and I think we would like to do that. There's some other use cases we've got that would require that we haven't tried yet.
Right. Thank you. Right. No more questions? So it seems like there is no really negative feedback for CloudBuild. It seems to do its work pretty well. And as you can see, it's not very complicated. As long as you can have a Docker container and do what you want to do, then there you go. It's just going to run it for you, which is quite nice, because who wants to run something nowadays? All right. Yeah, Joe, up to you.
All right, I'll just quickly close it up, guys, before you can devour the pizza. So yeah, guys, just to let you all know, we're partnered up with the likes of CloudBuild, HashiCorp, Docker, and sort of the main leaders sort of in the DevOps tooling space. So if you guys are currently undergoing any current challenges that you may need help with, or maybe some workshops, or maybe even a bit of training, we can help you with that. And we have helped many people along that journey as well. Last sort of recap, we are always hiring. I'm not a recruiter, but I just get told to tell you guys. So yeah, if you're not even in the DevOps space and you want to potentially go into the DevOps space, it's a great place to start. Thank you, Michel, and the pizza's arrived, so enjoy.
And everyone, thank you.